Welcome to the Industrial Control System Information Sharing and Analysis Center's monthly public briefing. We'll take another minute or two to give those who are still logging in a chance to complete the process. During this time, I will provide some housekeeping guidelines. If you're calling in on the phone, you will find a PIN number on the GoToWebinar application. Please enter this PIN into your phone and press pound. This will allow us to manage any background noise. My name is Debbie Wendell, and I will be moderating today's session. I serve as Community Director for the Center and oversee the Center's human-to-human information dissemination mechanisms. In case you're not yet fully aware of the full range of collaborative products that we have to offer, make sure you check out our LinkedIn group, Twitter account, and website blog posts. Plus, we hope that you will take full advantage of these monthly briefings, as well as our Thursday open forum discussion sessions. Our goal is to get our members accurate, timely, and actionable information in a way that best suits their needs. Today's briefing, Cyber Everywhere, the Emerging Threat of the Internet of Things, features a panel of distinguished subject matter experts, including Bill McGee, Senior Manager for Security Solutions at Cisco Systems, Dan Miller, Information Technology Program Lead at Argonne National Labs Infrastructure Assurance Center, and Dwayne Melancon, Chief Technology Officer at Tripwire. ICS ISAC Chair Chris Blask will be facilitating today's discussion. During today's presentation, Chris will take the first few minutes to lay some background information to frame the issue. Then each panelist will be introduced and have the opportunity to present their opening remarks. Next, the panel will spend about 35 to 40 minutes for their discussion. Finally, there will be time for questions and answers and open discussion at the end of the presentation. At any point during the call, if you would like to ask a question, you may use the hand raise feature in the GoToWebinar application. When speaking, if you would please introduce yourself and indicate your industry affiliation. After the meeting, a recording of this session will be available on the Center's website. So now, without any further delay, Chris, over to you for your background presentation.
Thank you, Debbie. Thanks to the panel, all the people who are here today, and of course all you people out in the future listening to this. Hello from the past. So we're talking today about the connectivity of everything, the interdependency issues, and the people we have here, particularly on the panel, are particularly well suited for that. So this is a little bit of background. We're living in an interdependent world, and we've seen failures of interdependent systems already. We have not, to the broad public knowledge, seen the cyber-caused failures of these interdependent systems, but nonetheless the consequences are the same. So on the screen here we have a couple ad hoc examples. Going back to 1998, the failure of a satellite brought down U.S. pagers. I actually remember that day working with Cisco at the time, and pagers going down sounds like not much now, but it caused a lot of problems. It caused problems in the financial sector, caused problems in healthcare. In the summer of 2001, during the period of brownouts and so forth in California, a study was done looking at the economic loss, the job loss cross-sector due to problems with the power grid. And everybody remembers about a year or so ago, a natural gas pipeline rupture in West Virginia intercepted to the transportation system. So this study, you see if anybody wants to see this study, you can Google it up. This is from Dan Miller's colleagues at Argonne National Lab. This is a very good look at the interdependency and failure scenarios of interconnected systems. And when we put this together, we see that damage to systems, whether they're in power or water or in transportation or communication, have a ripple effect and have a cascading effect on the infrastructures that we all rely on. So while we quite often in the critical infrastructure world think of infrastructure sector by sector, there really is only one. And to the point of today's conversation, it's getting much worse or better, or one way or another interconnected, no matter how you think about it. And this isn't just a matter of cyber. This has been coming for a long, long time, since our pre-ancestors began controlling the environment around them and creating systems to allow them to take the resource and build the civilizations that we're used to today. They've gotten more and more complicated and more dependent on these systems. And as early as the Roman Empire started building the plumbing systems, that's an example of that image there. And through the Middle Ages, water is a good analogy of the interdependencies, because water was both transportation and communication information and power. So through the Victorian era, we're making more and more complicated, more and more interesting systems with all sorts of whirling little balls and chitty-chitty bang-bangs that are connected by networks of communication and transportation to more and more sophisticated systems to support the infrastructure that we need. And of course, this takes us to the modern era, when in the late 70s, a group of degenerate hippies in Dwayne's neck of the world started making things like Microsoft Windows and other computer systems that have gotten down into our infrastructure. And of course, the tipping point that brings us to this conversation is when one day someone said, maybe I should hook a computer up to this thing. So we have today the Internet of Things, the Internet of Everything. Companies like Cisco and Intel and so forth have recognized the inevitability of this to the point that it's a major driver of marketing campaigns and strategic development technologies. We see, as represented in this particular slide, large numbers being thrown out. They're probably, in my opinion, probably understated. 7 or more devices, millions and millions of connected vehicles, massive growth in industrial systems, all of it interconnected. And while we can think that we'd like to have separated systems, we still talk a little bit about air gaps. Obviously, that didn't work really well for the Iranians within the Natanz nuclear facility. And as we get more and more connected, and we connect everything from little pumping stations and orange groves in Florida to the light bulbs and the light switches and the refrigerators, but beyond that, the development of flexible technologies, we're now integrating computers and computer systems into the clothes we wear, into our bodies themselves, and into everything that we're used to seeing is becoming a cyber device. So all of this, in the end, is the reason that we as the ICS ISAC and our partners focus on the development of, the Global Knowledge Network. This is the overlay knowledge sharing that is in our view, the answer to the larger issues of security. Now, while we won't be able to, in a world of 50 billion connected devices or 100 billion connected devices or more, be able to make sure that every single device or even every single facility is secure, we can, inside the devices, inside the homes, inside the facilities, establish relatively reliable situational awareness to the level of what we expect from utilities and our infrastructure today. And as we are connecting those pieces of infrastructure with public sector, with private sector, with entities like the 3 panelists are representing today, we end up getting the emergent properties of security that will allow us to have this embedded system that we're all putting together. So I've gone on some length. Most of you are probably familiar with the SARA project, the situational reference architecture that the ISAC has put together. But basically, founded on the idea that in an interconnected and interdependent world like this, it's incumbent on every player to know these 4 things, to know who they are. I am a wastewater facility in Eastern Tennessee that's municipally owned. I have a staff of 5. I have these capabilities. I have these assets. I have these risks, these threats. To know what they have, know what it's doing, and to be able to at least consume information shared with them that's generated in the external world, and where possible, share some of this information with the rest of us. So with that, as an introduction, hopefully I didn't consume too much of the time. If Debbie, you would like to start around the table, we'll get initial thoughts from the panelists, and we'll take the conversation from there.
Bill McGee has been professionally engaged in the network and cybersecurity market for 25 years. He is currently a senior manager at Cisco Systems, responsible for security architecture and solution development. His focus is on the Cisco Secure Data Centers strategies for traditional, virtual, and intelligent fabric environments. Bill is a highly sought-after subject matter expert and is a frequent speaker at international security events. Chris, back to you.
Bill, if you want to take a few minutes and give us your thoughts to kick things off, the floor is yours.
Okay, awesome. So as we're thinking about the Internet of Things, clearly this is something that Cisco is quite interested in. There's a couple of things from a security perspective that are particularly concerning. The first is, as we begin to, as Chris was talking about, as we begin to move further and further out into connecting everything, and everything eventually has a uniquely identifiable marker of some sort that has a some ability to connect to or to identify in cyberspace, then there's a couple of issues, right? The first is, how do we manage all of this data, right? We're expecting about a 3,000% increase in data coming into data centers by the end of next year, by the end of 2015, and we see that growing exponentially out into the future. Being able to consume that data is one thing. Being able to parse through it and identify threats and critical information to be able to make decisions is even more difficult. And the challenge that we've had is that we've generally created a security environment where we've placed security devices discreetly around places in our network, and then hope that anybody who wishes to do us harm will accommodate us by filtering all of the traffic that has an attack in it through the collection points that we've put in place. And what we know is that most of the community that wants to do something bad, whether they're terrorists or hackers or whomever, spend most of their time trying to get around those sorts of things. So what we need, where Cisco is spending our kind of development energies on, is creating a more intelligent network environment. So rather than the network being just plumbing, my devices on my network should be able to immediately identify when a new device touches it. It ought to be able to say, hey, I know what that device is. It's a video camera, and I have rules for video cameras. Video cameras can transmit data, and I'm not allowed to request data, and if this camera starts requesting data, it's not a camera, and I'm going to drop it off my network. So, I mean, we start at the network layer, but when this starts moving out into things where my electric toothbrush can automatically order replacements for the replacement brushes, or my refrigerator begins ordering new water filters, what I don't want to have is 5,000 water filters showing up on my doorstep. And so we've really got to take that kind of intelligence and push it out into the cloud, push it out into the service provider space, so that we can make everything kind of a touchstone. And that's really kind of the critical thing. And the second element of this, and then I'll pass the ball here. The second part of this thing is that we have to think about threats across the entire threat life cycle. We spend right now about 70% of our security dollars on the prevention part of this, preventing bad stuff from getting into our network. But even if my security at the edge of my environment is engineered to 5 nines, right? I've got 99.999% security. That means literally hundreds or thousands of malicious things can pass through that. There's no such thing as an impermeable edge that doesn't allow bad stuff through, which means that my strategy has got to move from just the prevention side to the before to the during. What do I do? How do I detect something bad that's happening? How do I detect malicious or anomalous traffic while it's happening? And what do I do while that's happening to detect it, to block it, to quarantine it, those sorts of things. So the during has got to be a fundamental part of how we think about these things. And then the after. How do I quickly remediate my environment? How do I bring things up to spec? What do I learn from this in order to be able to protect? And most analysts are predicting that shift, there's going to be a dramatic shift happening away from the before piece, and we're going to see more dollars moving into the during and after. Continuous assessment rather than occasional security validation. And then if I've got continuous assessment, then I need to have continuous remediation. And how do I do that? How do I identify every device? How do I manage that? And those are all the real big issues around the Internet of Things that we're looking at.
That's very well said. I'm not going to break the protocol and throw a little my own comments in there. So Bill, as you're very aware of, this is, all of these things take an awful long time. And I think Cisco is a great example. Cisco is very visible. We're all familiar with it. And it's in the IT space primarily. A lot of, work the ICS ISAC, a lot of our members are focusing on ICS. We look at the difference between one and the other. And quite often, the ICS space feels a little, there's a paucity of deployed security solutions and expertise and so forth. I think it's important to understand that we're still developing this stuff in IT. We are far from robust and mature. And as you know, the development, the concepts of the Cisco Safe Network and the self-defending network, while perhaps, these things haven't really come to fruition, it's not because they're wrong. Everything you said is that continuation of that same linear development. The network itself has to be aware. We're just not there yet, but it is absolutely where we're going.
And there's been dramatic improvements along that line just in the last year as we move from kind of traditional, port and block and tackle based sorts of data centers to application and software centric environments where ports and physical location doesn't matter, and being able to provide kind of ubiquitous policy and control regardless of where any of this data or traffic exists. We're really developing, not just Cisco, but across the entire IT industry, real intelligence into that space. And so we have a long way to go, but we have made huge strides towards identifying and addressing this. The big issue, I think, short term is going to be being able to consume and manage big data.
Yeah, and this maps again with one of our iterative themes that, while the ICS space has a lot of challenges, we cannot logistically just, and financially and temporally, deploy the traditional IT solutions at every existing infrastructure facility in the nation, much less the world, in the time we have left before, the inevitability of large-scale attack and consequences hit us. What we can do, however, is, and particularly because of the nature of these systems, because they aren't as complex, they are, quite often, almost ubiquitously today fixed. We can put in that network awareness. We can put in that that self-defending network, if you will, capability in industrial setting much more quickly, much more easily, than we can in IT. So, without slowing things down too much, if Debbie, you want to give Dan an intro, and Dan, I will make you presenter now while she's doing that. I know you have some slides to show.
Dan Miller has been developing and analyzing systems, energy, and infrastructure at Argonne National Labs for 27 years and currently leads the Information Technology Program for their Infrastructure Assurance Center. Argonne IAC activities are focused on assuring the security and resilience of U.S. critical infrastructure and key resources that may be threatened with disruption from either cyber or physical threats. Dan's work in recent years has focused on processes and systems that collect and integrate information on critical infrastructure components, their interrelationships, and interdependencies. Chris, back to you.
So Dan, we have your slides up there. If you want to take some period of time and give us your thoughts to start things off, that would be lovely.
Thanks, Chris. Just a little bit of background about Argonne, if people aren't familiar with it. It's an FFRDC, a federally funded research and development organization. It's the first national laboratory, founded in 1946, and performs a multitude of tasks and has many programs. As a national laboratory, it's originally founded to support the development and of nuclear energy. It has moved on to multiple additional fields, and in particular, infrastructure assurance, national security, and cybersecurity. The organization that I'm part of and representing here today is something called the Decision and Information Sciences Division. DIS has a number of missions, primarily related to modeling, national security, energy and the environment, cybersecurity, and social dynamics, including some of the social engineering exploits that are becoming quite a bit more common. The Infrastructure Assurance Center was established in 1998, but was built upon a number of previous activities that have led up to a lot of very relevant areas supporting this type of analysis. For example, environmental analysis is essentially an interdependency exercise. As we've all learned, in some cases to our sorrow, difficulties and problems in the environment can spread to all aspects of everyday life. We are fortunate to no longer suffer from the effects of acid rain, but in the 70s it was causing damage to vehicles, damage to outside electrical equipment, hurting crops, hurting animals, and programs to reduce that seemingly unobvious interdependency provided a lot of benefits. So some of these slides now are going to look very familiar because Chris showed a few of them during his first presentation. But some of the keys to understanding the criticality of interdependency and why industrial control systems and SCADA systems and cyber systems have accelerated and exacerbated some of the risks and vulnerabilities related to interdependency can be seen from a review here. I'm going to try and talk about a few of the more specific incidents and areas that have shown why ICS and interdependency have been accelerating in their criticality. There's been increasing recognition of the importance of the various sectors, both individually and collectively, as an interdependent whole. Recently, Presidential Policy Directive 21 was issued and redefined what were once 18 critical infrastructure sectors into 16 critical infrastructure sectors. It's the interdependency between these sectors, and in particular, the degree to which cybersecurity and cyber control is now affecting and adding new risks to all of these sectors that's at issue today. When we first started looking at a lot of these systems 25 years ago, it was interesting because when we would go on site visits to various infrastructure facilities, cyber and communications, remote access control, in many ways they were more sensitive to some of those issues back then than they have been recently. The organizations controlling power plants and transmission lines, natural gas distribution systems, compressor stations. They generally used dedicated communication channels that could not be intercepted or taken over, and the notion of using a publicly available phone line, or that was very early internet, was anathema to the guys running these plants. It was an obvious risk that that they wouldn't consider. In more recent years, I think with social media going everywhere, with so many people used to the notion of sharing a lot of their information on Google and on Facebook, etc., there was a reduction in sensitivity to some of the risks of exposing a lot of these systems. And this discussion here today, I think, is a great example of the recognition that we need to rethink some of that exposure and tighten it down. Early efforts that we worked on involved analyzing distribution of natural gas, in particular international shipments, and the systems that protected and monitored them. The energy distribution networks, and in particular the SCADA and ICS systems that monitor and control them. We've done examinations of defense facilities and their interdependencies, and that's, of course, since 2000, and the events of 9/11, Homeland Security has become a huge issue for everyone. One of the problems that we all face as we start looking at the interdependencies that can be affected by these cyber control systems is the sheer magnitude of the number of systems that it would be necessary to consider when evaluating risks and threats due to interdependency. There are literally millions of systems that are interconnected today and in some ways can affect day-to-day operations of anyone's facility or organization. This cartoon brings up the notion of a cascading power failure that solves itself, but a transmission tower knocking out a pipeline, knocking out a train into a bridge, into a natural gas line, setting a neighborhood on fire, being rescued by a sinkhole caused by a failing water main. Plausible, not probable. Chris was kind enough to put up one of the key conceptual diagrams that was used to try and pull out many of the potential interconnections and interdependencies between the various infrastructures. I've got a good example that Chris touched upon earlier that shows some of the perhaps not intuitively obvious relationships between even as seemingly indirect an effect as an economic or regulatory change, and how that can result in an operational failure of a downstream system. So that example that Chris alluded to was a severe problem in California in 2001. And among the failures was failure of crop irrigation, loss of food production. The interesting thing is that crisis, when it was fully analyzed, could be traced back to a legislative change that was designed to deregulate and in electric markets increase competition. The hope was to provide improved availability and reliability of electricity, but the actual effect was to cause this cascading series of problems. This type of incident is becoming easier and easier to set up due to the increased speed at which these interconnections can manifest themselves. So looking at that event, there was a logical cause, a financial market change that led to physical impacts in downstream markets, exacerbated by the speed at which cyber systems can drive changes in physical systems. So that particular event had it was a good example of a cascading failure that turned into an escalating failure, and it illustrates the operation of these interdependency failures. This is another view of the many interdependencies that can exist between power generation, power consumption, for example, a gas pipeline, which may drive power generation that can cause a positive feedback scenario where one change actually makes another change worse. In attempting to model the entire interdependent infrastructure, a great deal of information needs to be pulled together. And Chris's effort with Sarah to identify this multiple series of interconnections, hopefully will someday make it possible to do a better job of modeling these issues. Again, this is that kind of delightful diagram that Chris showed briefly earlier. But one thing to note here is that one connection that exists between every aspect of this infrastructure is SCADA and communications. The vulnerabilities that have become more and more apparent in recent years can now drive failures in every one of these infrastructures, and failures in every one of these infrastructures can in turn drive failures to the SCADA systems. There are many initiatives going on right now in the private and public sectors. We've been working with NIST, update cybersecurity standards. We're working with the chemical sector and the CSAT program to collect information on the chemical industry, one of the more potentially vulnerable industries due to the vast number of SCADA and ICS systems that are could potentially be disrupted by interdependency failures, and a number of other programs here. Another change that, or at least a newly emergent risk, has been that it's not just the ICS and SCADA systems that can be vulnerable due to their connection to the internet. In other words, as we've gone from dedicated lines to everything being connected to this everything connected internet, the risks are always, or generally are being seen as risks to these control systems. But that huge target exploit, where a great deal of private information was taken, has at least been reported to be due to a weakness in an HVAC control system. In other words, the industrial control system that was running HVAC at target had cyber vulnerabilities. Those vulnerabilities were exploited, and that wound up letting the attacker put in place a base behind their security firewalls and let them in turn extend their attack to other systems. It's a great example of the interdependency within the cyber sector of traditional financial and control systems and the vulnerabilities that are seen in hardline control systems. And that was a fairly new one, and I think it surprised a lot of people. So that's the end of the slides. I hope that was of some interest. And Chris, back to you. Chris, you're still there?
If we lost Chris?
I don't know. He may be talking to his mute button. Chris, are you muted? Okay, well, apparently we've lost Chris. So let me go ahead and introduce Dwayne, and then you can give your spiel. So Dwayne Melancon is Tripwire's Chief Technology Officer, where he owns a critical role in driving and evangelizing the company's global overall product strategy. He brings over 25 years of security software experience and is responsible for leading the company's long-term product strategy to meet the evolving data security needs of global enterprises. Since joining Tripwire in 2000, he has spearheaded numerous initiatives, including executive responsibility for business development, professional services and support, information systems, and marketing. Prior to joining Tripwire, Dwayne held leadership roles at DirectWeb, Symantec, and Fifth Generation Systems. He is certified on both IT management and audit processes and is a frequent speaker at national and regional industry events. So with that, Dwayne, why don't you go ahead and give your introductory comments, please.
Okay, thanks a lot. Yeah, I don't have any slides, but to me, when I think about the Internet of Things, I mean, it's it's a cute name, but really it's just the Internet, right? And we're just adding more things to it. And I think one of the challenges that is interesting to me about this is that the lines are blurring a lot more quickly than they have before. And what I mean by that is that kind of the lines between consumer versus enterprise class devices is blurring. The function blurs because now as we allow consumers to put more things on home networks, whether they're smart devices or IP addressable in any form, and then allowing them to connect to networks that belong to critical services, you end up with this, the kind of metaphor I use for it is you can't pick up one end of a stick. You want this to be convenient, easy, and low cost, but you've got to consider the implications of that when you connect it to things that need to be secure. And, I think a lot of the attraction for me with the SARA model is that really it's allowing us to provide a framework where we can increase awareness so people have more informed choice, but more importantly, understanding of what is going on so that you can actually zoom out and look at risk in a lot more holistic fashion. The line between ours and not ours is getting a lot harder to tell, and I think it matters a lot less. But the challenge is that as we get more consumers or small offices or small providers that are buying convenient infrastructure, convenient devices, and attaching them to the network, their skills are not where a professional information security person would be. So they don't understand logical segmentation. They don't necessarily patch and update. So you end up with a situation where you don't have a predictable security environment, and you're now blending personal networks, small office networks, larger public networks, corporate networks, and even critical infrastructure can blend in there, and we end up with this weakest link model. When you talk about like the HVAC vector at target, what that means is that something you don't control can compromise something you can control, and unless you really understand the interdependency between these things, home users, contractors, small offices, and other people can become vectors for attack into your critical infrastructure. And the barrier to accessing some of these devices and compromising them and using them as a vector is a lot lower now. We recently completed some research and found that 73% of the top 50 consumer routers that are sold on Amazon are shipping with easily exploitable vulnerabilities that would allow people to perpetrate a man-in-the-middle attack. A lot of them have software updates available to correct these problems, but I don't know that the average consumer is going to understand how to update that, or a doctor's office or an attorney's office or accounting office that has some of this convenient off-the-shelf infrastructure. I guarantee you the majority of them are not keeping up with security patches on their network infrastructure. It's all we can kind of expect from them to keep up on their desktop infrastructure. So we end up with this blend where it's really difficult to tell the difference between things we can trust and things we can't on our networks. And with that in mind, I mean, part of Tripwire's business is really dealing with vulnerabilities and security configuration compliance and things like that. One of the things that I wanted to point out on this is next week at RSA, we're actually making available a free tool called SecureScan, which is a utility that will allow you to it's a cloud-based vulnerability scanner that will allow you to, at no charge, scan up to 100 IPs. And we're hoping that we can allow people to use these on home networks and small offices and branch offices and so forth to get a better understanding of what's out there, how it's vulnerable, and at least have the information to make more informed choices. Because I think this is our new reality, and when you look at the name of convenience driving a lot of choices, we need to find ways to work in that with some security. One example recently came to light is that Comcast is now using its customers' routers to extend its Wi-Fi network for other customers, which means that now you've got devices that connect to things that you can control but are being used in ways that you can't control. That's important to understand as well, because you can't pick up one end of the stick. You've got to deal with this holistically. And for me, I like the fact that we're all engaged in a information sharing capacity with the ICS ISAC, because I think this is going to be part of what has to happen going forward for us to all be better informed and make better choices.
Very well said. And we experienced a little bit of that, interdependencies and resiliences. My telephone dropped out at a key point, and because we have options, and because there's more than one of us here, we actually get the conversation going. So it's fascinating how this all comes together. I'd like to, since I think it's for my comments, and Dan, I had 3 thoughts for you. One, I love that cartoon. I want a copy. But another one is to look at, supposed to point out for all of us here, particularly in the context of all of the CPD 21, the cybersecurity framework stuff that's going on as we speak. For all the limitations of government, for all perhaps that the private sector has been looking too much to government, which we're working through that process right now, it's important for us to understand the asset we have. What you talked about with Argonne National Labs, and what I've seen with the output, the reports and so forth you guys put together, these are enormous resources that we can tap and that are out there that are critical both for us to understand so that we can use them, and to understand that we're not just coming on get into this on Wednesday. Some of those people like yourself have been at this for decades, literally, and it's adding up. We're getting to the point where all of these things can come together, and we will, in my opinion, successfully build this. As Dwayne correctly says, not Internet of Things is just a word. This really is just the expansion of the Internet. But Dan, the one thing I wanted to ask you, with your extensive experience in government / pseudo-government, as an federal research development center, if you want to share your thoughts and comments both on PPD 21, the cybersecurity framework, and whether that's good, bad, how you do that going forward, and then applies to all of this, and the role that the labs and the public sector can play. That wasn't a too convoluted question.
Sure. First of all, the new framework is I think evolutionary rather than revolutionary. NIST 853 has been around for a long time. A lot of the basic concepts of maintaining secure networks and secure facilities, the systems that Cisco's been putting out for years have provided many extremely useful tools for making networks secure. Tripwire is it's sort of a standard in the industry. It goes back many, many years as originally as a way of checking the consistency of the configurations. But these tools have been there for a long time. The difficult piece, I believe, and we run a number of production data centers and support other data centers at other laboratories and design systems that need to be secure. The biggest problem is maintaining day-to-day operational security, not letting your guard down, making sure that you, just as Dwayne was saying before, it's so easy to let the day-to-day urgencies get in the way of patching and scanning. It's why we've been very happy to been able to implement a number of these automated scanning systems that we do continuous scanning of all the systems, and the initial implementation of those systems was an awful lot of work, took a lot of staff and a lot of money. it's nice to see that commercialization of a lot of those capabilities is going to bring that functionality down to everyone, to small offices, small businesses, and just as important, large businesses and operational facilities that can become problematic if some of these interdependency exploits are exercised. PPD 21 also implies the extension of some control and some regulation of systems, and that's a little bit more controversial. The degree to which you're going to have to comply with some of these standards and the degree to which there'll be recommendations and support, I think that's an ongoing discussion, and it's a policy piece that DHS, I think, is going to have to address. We have been heavily involved in regulation of the chemical industry that's been taking place in the last few years, and that certainly the data collection aspect of that, I think, was quite a success, and keeping those systems up and running was something that benefited greatly, I think, from a lot of these existing programs.
Yeah, and that was a couple of good comments in there. And you're right. Tripwire, as an example, obviously we know Cisco's sort of ubiquitous out there, and those of us who have a long history with them understand that there are pieces. There's a lot of good things. In fact, the internet's up and running right now, which 20 years ago a lot of the best people in the world thought wouldn't happen. And I've been witness to Tripwire in its open source and commercial forms being used in all sorts of applications, and embedding, as you say, as a standard in military applications and various other things. So it's yet another indication of the hooks that we already have out there. And so tomorrow we have a conference with NIST and NERC and American Water Association, McAfee, on the NIST framework and how it maps through the things. And this really is the theme. It's evolutionary, not revolutionary. It's important that we understand that these things have been coming for a long, long time. And we're not starting from nothing, but we're also not we're not about to be imposed on by overlord, whether it's Cisco or the government or the big companies or the small companies. This is a complex ecosystem. And if those emergent properties, I find myself using this term more than I'd like, but it really is. It's not whether or not we're going to connect these things. We are. It's not whether or not there's specific risk. There's certainly not. But it's getting ahead of the curve part so that we can deal with the emergent properties we're not expecting. So, Dwayne, your thoughts on recent regulatory moves and the framework on all these topics, if you'd like. And Bill, feel free to chime in as well. We're into our last 10 or so minutes.
Yeah, I think it's good. I mean, I think, to me, anything that allows us to come at this in a more orchestrated way. I mean, one of the things I like about a lot of the standards is that there's much more of a focus to a risk-based or top-down risk-oriented view, which I think is the right way to go. I mean, in the past, a lot of the criticism I had for certain frameworks was that they were a little too cookie-cutter, a little too one-size-fits-all, and I think one of the things that we need to develop as a competency across as many organizations as possible is a good way to understand how to articulate risk, how to get through the analysis, and then how to get everybody on the same page about that so that you start to break down some of the silos, you start to deal with things more systematically and more holistically. And I think the topic today around Internet of Things is definitely one of those that forces you to look beyond your own sphere of control and to get you to engage with third-party stakeholders so that we're all kind of looking at risk the same way, or at least evaluating it in a similar enough fashion that we can get confidence that, okay, I trust your security practices as a provider. I will allow you to connect to my network, but I also want to have controls in place so that I can monitor and detect what you're doing and make sure that if I see anything suspicious or out kind of an outlier, that I know what to do with it. And to me, a lot of the NIST framework is no exception. It's got a very much risk weaves through this, and I think as we start to engage more with, I think just to take a step back, one of the things I think that is happening in this discussion is that we're shifting away from talking about IT risk and just talking about risk, because IT is so now interconnected with everything that's going on. When you look at business or organizational or mission risk, you've got to consider every piece of it. It's people, it's hiring practices, it's background checks, but it also is the cybersecurity aspect of it, and the devices that your trusted people will connect to your trusted network. And I think we've got to get better at dealing with that holistically. And I think some of these frameworks are a big step in that direction. The other thing I think that's got to change at some point is, we're still early in a lot of these cheap connected devices, but there are no standards. So, right now, if you buy 3 different smart light bulbs from 3 different providers, you got 3 different apps to manage it and 3 different methods to look after them. There are no standards there. I think we've got to get to a point where there are more standards to bring manufacturers together so that it makes us easier to manage things as a herd, and not trying to deal with things as a pet, because a device can't become a pet because it takes too much time. We've got to be able to deal with them in herds, and standards are going to play a big part in that.
Herds and pets.
Yeah,
Love that one. Go ahead, Bill.
I was just going to say that the challenge, of course, is that the environment is escalating at such a pace that it's very difficult for standards bodies to keep up. I mean, that's always been the case, but more so now, I think, than ever. And so I think having a kind of a general framework of how you're going to plan and design and implement and respond to, the environment is fundamental. I mean, the last 2 years, I've been fielding nothing but panic conversations from folks who are just trying to figure out how to get mobile phones securely connected to their network. And not that we didn't see this coming, but they had no strategy in place. There was no plan, and and they tend to have siloed this. I need to connect it to the edge of my network, and then the edge of my network needs to connect to my data center, and then my data center. And rather than seeing this holistically, is that the guy on the remote device needs the data in the data center, and I need a kind of a consistent approach to all of that. Because we silo this and we break it up into smaller chunks, it makes it much more difficult when something new, a spanner gets tossed into the works. And so that's really the challenge, is we've kind of got to wrap our heads around a different way of looking at securing this environment, because it's coming at us fast and furious, and we don't have time for legislative or standards bodies to provide us with hand-holding.
Yeah, there are some things that when you look at, a lot of the consumer-grade routers are now making it easier for people to deploy them with more secure practices, trying to prevent people from leaving default passwords in place, things like that. I think that's a step in the right direction, and I think if we can start to see more, there's this kind of fabric that can help, where if we start to see more guidance on how to establish different zones on a home network so that you have, appliances that should never talk to laptops and desktops on one segment of the network, and then the things that access your banking account on a different part of the network, just to make it harder for things to blend, those will help. But, the challenge is we're now taking people who are in, mass market mode and expecting corporate security mode behavior from them, and it's just not realistic. So we've got to find ways to make it harder for people to mess things up inadvertently.
Yeah, exactly. And the problem, as you described earlier, was that these mass market, easy to buy, easy to deploy stuff, and the enterprise edge, they're merging, and not just accidentally, on purpose. We're actually blending these things together, and we've not necessarily thought through the implications of all of this from a security standpoint. And bolting this on later is not probably their best strategy.
And there's the asymmetric nature of cybersecurity risks and vulnerabilities is counterintuitive. We've got thousands of years of experience with physical vulnerabilities, and to get through a thick wall, you need a big siege engine. And if you want to steal a warehouse full of stuff, you need a huge long line of trucks. But with a cyber vulnerability, instead of a 99% solution removing 99% of the risk, a 1% failure is often a total failure. All it takes is one of 500 controls to fail, and you'll lose everything.
Yeah. Well, not only that, but for all the physical vulnerabilities, I have to go there. There's an effort involved, you know, but for a lot of these cyber ones, I don't have to go anywhere. I can sit in my house and ping away, and, oh, I found one, I'll attack it, you know. So the barrier has really changed dramatically.
Right.
And I think it's still difficult for people to kind of get their head around that. They think that if they've got a firewall up that's 99% effective, that they're okay, and only a little bit of their bank account can trickle through. Not the whole thing all at once.
Right. And that's exactly what I was talking about earlier, right, about changing our perspective from building the wall that doesn't let anybody in to begin looking at the entire threat continuum, right? This, you know, certainly you want to build a wall, but you need to look at before, during, and after is the entire life cycle of a threat, and make sure that you've got a strategy in place that covers that entire thing, because the reality is something's going to get through, and then what happens, you know, and then what do you do to, you know, to clean up the mess afterwards, and that's got to all be part of this. So, you know, castles were designed specifically so that I could, if my outer defenses were breached, I could lock down the inner one, right, and I could, you know, I could move in, so I didn't have to sacrifice everything at once. And we have to think about how do we contain attacks when they happen, and how do we manage what's going on during the process, and how are we aware of stuff that's happening if it's managed to bypass whatever the, you know, the security component that we've put at the edge to kind of alert us.
Well, there's always so many good points in these conversations, you know, just to capture a couple of us, we're done in the last couple of minutes, but the three of you have all said in the last few minutes, you know, we don't have standards necessarily to address some of these issues. You know, standards are developed after the fact. That's by nature. So by the time we figure out how it's normally done, we already know how to do it. It's just a matter of spreading that mean. And you know, we've gone on record, you know, in the cybersecurity framework that we think it's a wonderful thing. It's gone better than we expected. However, you know, situational awareness and that ability, as all of you have said, you know, to see what's going on, you know, that's not part of a thick wall. It's not part of the standard approaches that we tend to have. It is, however, you know, given the, Dwayne, as you're saying, you know, and you know, Bill both saying, all three of you, it's a different thing. You know, I can steal the car out from underneath the paint, so it's just not exactly the same as keeping a lot of gold in a safe. But because, you know, all of the conversations that we have, this is what we do all the time, every day, all week long, is have these conversations with brilliant folks like you and the audience out there and people in public and private and internationally. And what we see is that there's a strong awareness of the complexities of what the nature of those complexities are. You know, even the emergent properties beyond the fact that they're there and they need to address it. And there's a lot of components, work that Cisco has done and Tripwire has done and Argonne, the other national labs, as a great example, that have been built up and perhaps not used everywhere, or perhaps not ubiquitously deployed. But this is what's behind the solutions that we're putting together, all of us, you know, today and next year and the year after. It seems very clear that you know, the time frames each of you have mentioned, these last several years, these next several years, this really is going to be a very pivotal point. We do have failure scenarios where maybe we screw this up completely. But if so, it won't be because we don't have the ability. So final thoughts. We're at the top of the hour. In case anybody, our attendees are bouncing out, feel free to do so. But I'd like to give each of you a chance to say any final words if you'd like to put them out there before Debbie dances us off on sunset. Oh, actually, Debbie was telling me we have until 2:30 scheduled for this one. So we had been making these an hour. It might have been an hour and a half. So for those out there who may be leaving an hour, go ahead. Otherwise, we'll carry this one on until panel is done, say anything to say.
Yeah, I'm going to have to drop off in the next few minutes, but feel free to continue without me. And if you'd like, I can give kind of my parting thoughts. This is Dwayne, by the way.
Sure, fire away.
Yeah, so I would say that just to repeat a little of what I said in the beginning is that I think the key is really awareness so we can make informed choices, and understanding of the threat environment and the reality of our connected fabric is a key part of this. That's, again, one of the reasons that I think the SARA model for information sharing is extremely valuable. And then to also repeat around one of the tools that we'll have available on Monday, keep on the lookout from Tripwire for Secure Scan, which is a completely free cloud-based scanner that will allow you to scan up to 100 IPs in any environment. And I think this is a tool that will allow you to see, even on a home network or a small office, what do I have on here? What's talking? Are there any known vulnerabilities? And I think that's, again, information is the first step to awareness. So if you can find out what you have and how it's vulnerable, it's a great place to start.
Thanks. And Dwayne has also offered to send out some info to the attendees on some of the tools and tips and so forth. So we'll get those from him and send them out to everybody here.
Yeah, just one quick comment on that. We've run a blog, more kind of like a news blog, tripwire.com/blog, and recently we put up something about 5 tips for securing small office, home office routers. So I've actually sent this to a number of people that are not so security savvy that I know, and they've applied some of these. So hopefully we try to get people to learn a few tips and tricks to become more secure, and not do the, just kind of the ignorant but dangerous things that people tend to do as consumers.
Absolutely. All right. Well, thank you, Dwayne, for your time. I know you've got to run. We have one question from David and Matt out there. I want to throw this out there for Bill and Dan. And so I'll just read this out here. So do you see fundamental challenges with the concept of managing trusted communications for the Internet of Things? How do people manage which devices and applications can trust each other? It seems that the SSL trust model of the web is broken, and otherwise trust is implemented at the application layer. So Bill or Dan, if you want to.
So walk me through that question again.
Sure. Fundamental challenges of the concept of managing trusted communications. So speaking, so the manage which device and application can trust each other, given the issues that we have with SSL and everything else. I'm happy to throw my thoughts on that.
Right. And how do we create that trust between those things? Well, some of the kind of the initial work that we're doing at Cisco is around policy controls, and many folks who've been kind of paying attention to what Cisco's doing is familiar with this. And so what we've been doing, and we're beginning to pretty aggressively expand this idea, is that the ability for the network to identify devices coming onto the network based on a variety of contextual-based information. Where is it coming from? Where is it trying to go? Who is the user associated with this device? What do we, is there no user associated with this device? Can I identify exactly what it is? What time of day is it? I can put a whole bunch of contextual information together, and once I've established what this device is, I can actually apply a policy to that device. And the way we're doing it, and the way we're trying to drive forward with this, is we actually create a little meta file, a little 16-bit meta file with the policy marker in it that we insert right into the header of the packet. And then as each packet traverses through the network, every network device along the data path can read that policy file and enforce it. So once that device has come onto my network, it's assigned to a very limited segment of the network. Think of it as like a dynamically created VLAN without any of the rules or VLANs that are associated with that. And so it can't ping sweep my network to look for things that aren't there. It can only do the thing that it's assigned to do. And if it begins behaving badly, I can log it, drop it, whatever, remove it and remediate it, whatever it is that I need to do. And so by weaving policy directly into the traffic chain, it gives us a better set of, A, I can identify what that device is, but if I control exactly what it's allowed to do and nothing else, then to some degree it matters less whether that's actually the thing or not, because it's only going to be able to do, you know, what I've defined it to be able to do by policy.
Well, and of course that's a you know, brilliant way of looking at things, you know, primarily because it agrees with my own point of view. But this, you know, as you're talking, I'm thinking of, you know, a longstanding, you know, issue I've had with Social Security numbers. You know, that, you know, what on earth are we doing trusting something that we have written down, all of us, on God knows how many mimeographed, you know, store credit card application forms. We spam the world with this 9-digit number, and that is actually supposed to identify us as somebody, which is insane. And in the same sort of way, you know, whether it's just an IP address or just even, you know, as David brings up, an SSL certificate, you know, why is it that someone can, you know, a 17-foot orangutan can walk in with my driver's license and I'm going to treat them like me? You know,
right.
When, you know, they walk into some place that I never go, looking like I don't look, doing things that I don't do.
Right, and here's the challenge, right? So which in the cyberspace, right, I may be logging in from Chicago, and suddenly I'm also logging in from, you know, Eastern Europe. And the network needs to be able to federate and rationalize that and make a decision about which one of these guys is real and what am I going to allow them to do on my network. And the other challenge with something like you're saying, like Social Security number, is not only does that identify me or anybody else who has that information, but I'm not always me. Right? At different times of the day, I am doing different things, and my level of access for different things probably ought to be different. And so context becomes very important in terms of being able to context combined with reputation. If I can combine reputation and context together, I can get a much better handle on what I'm going to allow users and their devices to do.
Well, and again, we in the industrial space can take a lesson from what's going on in the IT space. You know, if you're exactly right. In the IT space, this is really, really complicated. You know, you may be, in fact, in Chicago, you know, logging in through Chicago and through, you know, Germany at the same time, and it's still you. That's just the way things work. But if you're a programmable logic controller, you're not. It's demonstrably, ever. You know, you really are where you are, doing what you do. You know, that water pump is not suddenly in South America. You know, it is where it is.
Right.
So where we see ourselves developing capabilities to deal with the complexities of the IT, quote-unquote IT side of cyber, you know, in these complex areas, you know, it becomes more and more clear how, while we have challenges in the industrial space that we sort of flagellate ourselves to death with, we have strengths and opportunities that just don't exist in finance, that don't exist in mobile devices, you know, accessing corporate networks. You know, a water facility is a water facility, and those gadgets and devices and the people using them, the applications they're using, they just don't change.
Right. Right. It's tough to spoof a water treatment plant.
Yeah, unless it's just completely blind. There is no context, there is no visibility, there's no situational awareness.
Right.
And these are, of course, you know, preaching to a captive choir at this point. But when I see someone show up a demonstration on how to break a control system, and they say, look, I'm going to plug my laptop into this network, and I'm going to span the network with billions of new packets, and look, I found a vulnerability, watch me exploit the vulnerability. The first question is, why on God's green earth isn't a light flashing somewhere as soon as you plug in, much less start sending all sorts of anomalous traffic that never happened before?
Right.
And trust gets at the interface between administrative and physical controls. And about the only way to effectively control that is with heuristic-based continuous monitoring and the kind of system that Bill was talking about. The labs, for example, have a federated system with automatic controls, and if a heuristic at one lab spots an issue, that's distributed immediately to the others, and those systems are shut off, and that can lead to sometimes somewhat humorous situations where one of our a facility that we had a fairly substantial interconnection and interoperability segment set up. For whatever reason, that site got picked up by a heuristic at a different lab. It propagates immediately through the federated system, and we find ourselves suddenly cut off from this directly linked system. And tracking that back takes a little bit of time. But the difficulty with these systems is the only way to have them work is with heuristics, and heuristics are good but not perfect substitutes for a traditional full administrative review to establish the authenticity and appropriateness of the exercise of the role. So it's tough. And then the difficulty comes when these heuristics trigger some of these terminations of connection, and end users get frustrated. People get frustrated, and they fight very hard to have you throttle back or turn off some of these continuous monitoring controls. Now, we're a federal facility where it's pretty easy for us to say, tough, that's the way we have to do business. It's a lot harder for a consumer organization or a business that's trying to ship product and run their plant to distribute manufactured goods or chemicals. So it's a very, very tough problem, and it gets back to that asymmetric issue where in almost every other industry, every box of cereal has a few millionths of an insect in there and a little bit of rat, and that's okay. But we can't afford to have even that, 1 part per billion of insect in our box of cereal, because it's that case where the whole ball game's lost.
Well, to a certain extent, we can, and for no other reason because we have to. If we can't tolerate that, then we're doomed. I really don't think we are. But the point comes down to, that our way of dealing with that has to be slightly different. Well, and I think the analogy does track. This is George Carlin, I think, making those jokes right back in the 70s. Bug parts. There's a certain amount of bug parts our body can tolerate, and both in how we build our interdependent infrastructures. The sniper attacking on a substation in California just in recent days has led to interesting conversations about the fact that we've built an electric infrastructure but it doesn't have resiliency, in large part, when it used to. So really, it doesn't matter if it's a cyber thing or not. You lose key parts of it. It just does, horrible things. So in part, it's how we build our infrastructures and how we look at it, above and beyond, as has been mentioned a couple of times in this conversation. Not just cyber, all risk. And inside the cyber risk, it's also been brought up a number of times. Let's stop saying, well, I'm going to keep my facility from ever being penetrated. Just assume we might be.
Yeah, I mean, exactly.
It does.
Exactly.
Yeah. So you get some bug parts in your control system. What do you do?
Yeah, you've got to be able to say, I'm going to do everything I can to prevent something from coming in, but you've got to spend as much or perhaps more time on what am I going to do when the inevitable happens and something goes down, something gets into my network, something, that bug part gets into the works and things to start, wheels start flying off. What do I do to control that, to maintain that as much, and to keep that from escalating, keep that from cascading down the line? And that's got to be the that's got to be where a lot of our attention is spent.
Well, this is one of the areas where I think we really do have advantages in ICS over IT. In IT, we over the last several decades gotten used to just stringing wires and knitting things together, and it all blows up. It's a big deal. But in infrastructure, for not just decades, for literally millennia, people have been dealing with the fact that blowing up is not just a turn of phrase. That things really blow off. The wheels really come off. And what do you do then? So we have a sociological benefit, I believe, in a lot of infrastructure. that we just don't have an IT. And it's been cause of some friction. I think the sociology problems are as much challenges as the technical, but just the communication across the IT/OT boundary is complex. And we, as even though some of us here have crossed that line in both paths, we're generally IT people, I think, and we can get our necks up and say, well, those OT people just don't understand, and it might be the other way around in some cases.
Yeah. I mean, the biggest challenge I think we face is that the environment around us is shifting dramatically, and perhaps the most important thing that we can do is to not apply our kind of traditional approach to those by default. We've got to be able to step outside of our comfort zone and think about this thing in a more dynamic fashion, and that, as I talk to the customers, both in IT and just in kind of the security realm in general, that tends to be the biggest challenge, is that we've always done it this way, or I've got a problem and these are the set of tools that I use, and so I just bring that toolbox over and I start hammering at solving that problem, when if you look at the problem carefully, you realize that tool set doesn't really apply here, right? Just because you have a hammer in your hand doesn't mean that that's the tool that is for that problem. And so we've really got to get, I think, ahead of, for this topic, the Internet of Things and this kind of cyber being spread out across everything. To get ahead of that, we've really got to think about this in a larger perspective and not try to apply kind of our traditional, point solution approach.
And I think that goes in both directions, across the IT/OT boundary. I've seen and been guilty of all these things where you're coming from an OT perspective, you're saying, look, just because you have long hair and talk fast doesn't mean I'm really going to listen to you, cyberpunk. And vice versa, kind of from the IT side, say, well, Grandpa, you may have been doing this for 50 years, but around here it's a new world. There's truths and falsehoods in both of that. Not every, the foot dragging, we all love picking on the air gap conversation, most of us, and some of us like defending it. I'm not one of them, but it's easy to see. It's like, look, I've never connected to the outside world. Dan, you talked about this a second ago. I'm just not doing it. The reality of, yeah, you are. But that doesn't mean that just because I may have been right about that, I can be right for the next thing. And there's so much maturity. We in the IT space and the infosec space is, let's face it, brand new. It's just started on Wednesday. So you can say 20 years or 40 years if you really want to scream party. We can bring up Alan Turing if you want to be a smart ass about it. But infrastructure has been developed since the dawn of mankind. Got 6,000 years of this. There's a lot to be learned there.
Well, and the most important thing is, it's the kind of that classic, I know what I know what I don't know, and I don't know what I don't know, right? There's that third one, I don't know. But you can't
no. Right? I didn't even know I didn't know that, yes.
Right. And that's the challenge, right, is that if you move forward with the assumption that no one can jump your air gap, you're just waiting for trouble. And so you've got to constantly be rethinking and reevaluating your strategy. Just because you don't think you're touching the Internet does not mean that you're protected.
And Chris,
if you think you're just going to lock down the PLC, you're also wrong. Sorry, Dan, go ahead.
Well, I just think you brought up a very good point, and one thing that's been observed by a number of people is the commoditization of RTUs and ICS in general. 20 years ago, all of these systems had custom assembler level based OSs to the degree that there was an OS, and it was very difficult for someone to exploit them. It was very difficult to understand anything about its interfaces or communications. It took a government basically to hack the centrifuge control systems in Iran. But as time has gone on, more and more we're seeing everything running Windows or Linux, and there's where there were once thousands of different effectively operating systems, and a successful exploit could only risk a tiny percentage of the RTUs and control units that were out there. Now, almost, if you can hack either Linux or Windows, you've got 90% of what's out there. And that's a real change that has taken place in the last decade or so.
Well, Chris and I think we're both in the same room when we watched a group of folks just remotely take over a nuclear power plant as part of a penetration test exercise, and it was pretty exciting to be in the room. They went, "Oh, we just we can see everything," and that's a frightening prospect when you realize that these are systems that can be taken over.
And it's, and these are also inevitabilities. And like any change is always hard. Change is terrible. We hate it, but nonetheless, it is what it is. And what Sam was just saying, it's we've gone through this. We're not done with it. The conversation will continue. But I think at the core of the industry, we've gone through this. Well, I'm not going to connect it. I'm just going to use analog. I'll just use this steam fitting. I'll be fine. That's not going to happen. The picture of the Orange Grove pumping station. I was just riding a dirt bike along a levee a few days ago, and I saw this thing. I had to stop and take a picture of it. And I've been talking to the people around here and look at the business model. So if I own orange groves or manage them, I have to pay someone to drive a pickup truck down to start this thing and stop it and do, check if it's running and whatnot. Or at some point, I can get a Windows-based, Linux-based, $150 wireless gadget put on there and lower my cost and the truck rolls and the maintenance and the fuel and everything else.
Exactly.
Chipboard system.
Oil pipelines. If I have a segment of the pipe that goes down, I have to launch a helicopter, right? I want a video that I can turn on and look and see if this is real or if a moose just happened to walk across past the sensor. And so those are big issues. And then if we move further, Internet of Things, I don't just want to be able to turn that pump on and off remotely. I want sensors in the ground that are going to say, hey, the ground's a little drier today than it was yesterday, and have it dynamically adjust the amount of water that's being pumped into my field so that I don't rot the roots or don't, stress out the plants because they don't have enough water. And that's going to give me bigger yields and more efficiency, and but at the same time, it introduces a level of risk.
Yep. On the ongoing resistance to modern society, this is, worth throwing out the end of this, particularly since I have more time. I thought, I'm of an age to have lived through the end of the world over and over again. I was assured by the grown-ups when I was a kid that the world would end here, had in my career, coming from control systems and IT and the security, then back to control systems. I remember listening to all the best people in the world, 20-something years ago, saying basically the internet as it exists today isn't going to exist today, but it's here. And certainly in the ICS space, particularly when we get into these talks about interdependencies, there's a great deal of concern, and the potential effects are enormous. And not but for the diligence of the people listening to this now in the future, people who are involved in this conversation, organizations like Cisco and Tripwire and the national labs and so forth, yes, those things would actually happen. But again, we seem to, we seem to have the pieces. So as, this is one of the reasons, that we as an organization push this point, because we think right now that it's worth saying that, yes, we understand why, a subject matter expert might be upset that someone's using Windows-based things to control shipboard systems from an iPad back on the shore. But the reality is that the cost and the other physical risks of flying that engineer in a helicopter halfway around the world in a hurricane create a situation where this is going to happen. The shipboard systems are going to be managed by iPads, but engineers on the couch in Toledo. So now what? Our job is not to stand in the way and say, you shouldn't do that. One of my favorite little little stories is the police officer saying, look, what policemen want is for you everyone to sit in a well-lit room with their hands on the table. But that's not going to work. So we're the police people in the world in this context. What we would like isn't going to happen. So what we need to do is work inside the boundaries to make sure that the wheels don't come off.
Can we supply the iPad with a hardware-based PKI signature key that's cheap, easy to use, and really secures the communications between that iPad and the platform? That's going to be the challenge.
Yeah, because at the end of the day, I can go off with on the risk side as much as anybody. If you can open the sea cocks of a oil tanker at sea remotely, do I need to finish that sentence?
Yeah. So, well, fantastic. So now we actually are in our last 12 minutes. Any last thoughts, the two you want to throw out?
Questions from the audience before we once again give Debbie the chance to dance us off in the sunset?
I see everything accelerating. The Internet of Things makes it possible to reduce inventories, to accelerate just in time. All of these systems now are going to be that much more sensitive to interruptions to the Internet of Things, and that's why it becomes more and more critical that we properly secure it.
Yeah, I absolutely agree with that. But the acceleration is the biggest challenge we have. Change is coming, and it's exponential. And a lot of organizations that I talk to aren't really ready for it. I mean, they kind of understand it at an intellectual level, but they really haven't done the work to prepare for that, and that's really kind of got to be the number one priority.
Indeed, indeed. So thanks again to you guys on the panel, to everyone out there now in the present, to all our various membership for keeping this organization doing what work it is we do. Anybody out there who is not a member of the ISAC, on the website, you can find it right there. We do these panel briefings typically every third Wednesday of the month, but we alter that based on environmental conditions sometimes. And we have our first conference in September, as you see on the screen there, at Georgia Tech Research Institute. This is specifically a solution-based educational conference, sponsored and supported, no cost to attendees, with a variety of training tracks from organizations like FIRST and others. So, Debbie, would you like to give us the walkout?
To our distinguished panelists, thank you all so much for your thoughts and insights you shared on today's call. And to our audience, I'd like to take this opportunity to invite you to a special public briefing, What You Need to Know Now About the Cybersecurity Framework, being held tomorrow at 1 p.m. Eastern, that features Adam Sedgwick of NIST and a panel discussion by industry experts. Our next regular public briefing will be held Wednesday, March 26th, and feature a panel of distinguished subject matter experts presenting Understanding and Implementing Shared Situational Awareness. Other sessions will be announced in our monthly updates, on our center's website, and in our other communication vehicles. Thank you again for your participation on today's call.